All right, we're on the air. So, who wants to open with our our opening prayer and our closing prayer? It's been a long day.
I can say it.
Okay, go ahead, Taylor.
Our Father in heaven, we are grateful for this day and are grateful for the opportunity to gather as a group and to continue our education and our knowledge on statistics and on this math course. And we pray that thy Spirit might be with us, that we might be edified, and that we might better understand probability and those things that we've gone over, and help us to be able to express clearly our thoughts and the things that we have learned. And we love thee and thank thee, and we humbly pray and ask for these things in the name of Jesus Christ. Amen.
Amen. Thanks. All right. So, let me set this up. What is set up for? What? Where I can see my homework answers too.
Yeah, I'm trying to pull mine up too.
I know, I'm like, okay. How did I do this last time? Okay. 1 sec. All right. So, did we have any issues with the part 1 of the preparation assignment?
No.
We understand the notation is the P and then the parentheses with the X in the middle?
Yeah.
Okay. And then the rules of the probability. So what's rule 1, Taylor?
Probability is between 0 and 1.
Perfect. What's rule 2, Jenica?
Pretty much if you list all of the outcomes, they're going to be equal to 1. All the outcomes or the probabilities are going to equal 1 in any experiment.
Perfect, perfect. And rule 3, or the complement rule, what's that, Greg?
That is when the probability is not going to occur, it's 1 minus the probability that it's going to occur. So what you have left over.
Perfect, perfect. Okay, and we understand what it means to be random. That it's not just haphazard with no pattern, but that eventually we'll be able to discern the pattern over time.
Exactly.
Yeah.
I thought it was so funny in the reading. I was like, I went and bought some random things. The statistics are getting to me.
I know. It's awesome. Gotta find fun things to laugh about, right? Some of the reading is so dry, I'm like, oh. Okay. So what does the phrase discrete random variable mean? Did we figure that out?
The random variable is discrete if the values can be listed in principle given enough time.
Perfect. All right.
Is it overlapping for you guys?
What? No? Is it overlapping for you?
Yeah, I'm like getting a ring. But... Oh. Sorry, guys. Yeah, I was like playing in the background.
Oh.
Mine is paused. It doesn't look like it's playing. Was it playing in the background for you, Greg?
Yeah, it was. Did you guys hear that?
Mm-mm.
It just randomly started. Anyways. Sorry about that.
It's all good. Okay, so part 2. Do you want to just go over it? Do you want to talk about it if we had issues? What do you guys want to do?
I think the math was pretty straightforward. I mean, somebody needs help with it.
Could we go over? Yeah, the first one, number 5, was pretty straightforward about because of the 4-sided dice. Just times it by the probability. But could we go over the standard deviation?
Yeah.
Do you guys get that?
That one was the hard. I had to do it a couple times.
Yeah.
I think once you figure out like the formula, it makes a lot more sense. But
Yeah.
I just had a hard time finding the formula.
Well, what I did is I copied and pasted the table from the textbook, and then I just, like with the 4, since we're using a 4 dice, I took out the 5 and 6 rows and just replaced all the values with what it would be for a 4. A 4 die. So, but we can go through that for sure. So do we want to go through number 5, or do most people get number 5 and understand it? And
Yeah, I think 5 is fine for me.
okay.
I'm good with 5.
The mean was 2.5, right?
Yep.
Okay. Then the standard deviation of this discrete random variable. So I copied the table that had the 4 columns. It has the value, the count, the value times the proportion, and then column 4. I copied that out of the textbook and just copied and pasted it. It's the one that has the 6, because that was the example they were using, is the 6 dice. But we're using a 4. So I just took off the 5 and 6 row and replaced the 1/6 for 1/4, 0.25 for the probability, right? That we would roll a 1 out of a 4 die. So basically, that's all the same. Column 1, column 2, column 3 is all the same. It's the column 4 which gets fun.
Yeah, to find the variance.
Yeah, so basically what you're going to do is you're going to take your value, which is on the first row, it will be 1, minus your mean, which we found that the mean was the 2.5, right?
Yep.
And you're going to square that. And that's going to equal 2.25. Let me know when to go on, Greg.
Yeah, maybe I was plugging it into my calculator. Did you just do each one individually? Or did you just throw it all on the same line and then divide it by something?
See, this was my issue, is when I tried to do it just in my calculator, I kept on getting a wrong number.
Yeah, that's...
For me personally, math, I do better with math things if I write out kind of each step. So like I did 1, like in parentheses, 1 minus 2.5 squared, and I found that answer, which is 2.25. Then I multiplied that 2.25 by 0.25, which is the probability, right?
Mm-hmm.
And that equals 0.5625. But I kept on getting this crazy number because somehow I wasn't squaring it right in my calculator, and then that messed everything else up. And anyways, math is difficult for me, so I just I take it kind of step by step and break it down. Then the next one is, so it would be 2 minus 2.5 squared equals 0.25 times 0.25 is going to equal 0.0625.
Wait. On that one, isn't the, let me see, the third column, isn't your answer 0.5, not 0.25?
For?
It's on your second probability. Hold on a second. Let me pull up my little thing. It's what is the third column again?
The third column is value times
proportion.
Yeah.
Yeah. So it's not going to be the 0.25, right?
Well,
because if you take the value, that's 2, and then you would times 2 times 0.25.
Right.
Correct?
Yeah.
Negative
But you have to take the 2 minus this
2.5. Yeah, but then she said it was the 2 minus 2.5 squared times 0.25, but right there shouldn't it be times 0.5?
No, because we're timing it by the probability, not by the value times proportion.
Yeah, so the probability will always remain the same for each of those.
Oh, because I got the right answer at the end, and that's how I did it. So I was like really confused.
Like I said, I copied the table, and the table formula has x minus the little like u crazy thing, which is the mean.
Did was
and
I
then
did
times px. So I was like, oh, the probability is 0.25. So I just plugged in the numbers that I had in my chart. So I didn't use the value in proportion because the formula that they were giving us didn't use the value in proportion. Does that make sense? Okay. So on row number 1, I got 0.5625. On row number 2, I got 0.0625. Row number 3, I got 0.0625, and then row number 4, I got 0.5625. So you got something different, Jenica?
Yes. But for some, I'm pretty sure I got that right, because the final answer is 1.8, right?
For the standard deviation, it's 1.118.
Oh, then I read it wrong, so I did the math wrong on that one.
Okay.
Okay, so I see what I did wrong, though. It's really easy to fix for my thing.
Okay. So basically, like Howie said that we can have a cheat sheet, I'm just going to copy some of these tables into my cheat sheet so that I can use it for any example. You know, 1.6, 1.4, whatever, and just plug in for the equations that I need.
Yes.
That's my plan, because I'm not going to be able to memorize all this.
Yeah, me either.
So, and then once you find your variance, which it said it was 1.25.
Mm-hmm.
Then you just take the square root of that.
Yep, for your standard deviation. And that was 1.118. But that took me some time. That's why I break it down, because I was getting these crazy numbers and getting so frustrated. And then I was like, Lexi, you know yourself. You know math is hard for you. Just break it down. You don't have to do it all in your calculator. So it takes more time for me, but it's worth it if I get the answer right. And don't get frustrated. So do you think we understand these concepts enough to go on to the quiz, or do you guys want to discuss it some more?
Okay, can we go over, while I hurry and plug these back in, can you read the answers really fast so I can change them and make sure I'm getting them right?
Yeah, do you want, like, the...
Number 2, the column, let's see, it would be the, so after you do the 2 minus 2.5 squared times 0.25.
Mm-hmm.
I have the first one is obviously 0.562, and then the second one,
Are you there, Jenica?
Yeah.
Okay. You hear me? You're breaking up for a second. So you have it as what?
0.0625 for the second one.
Mm-hmm, that's perfect.
Okay, so I'm doing the math right. I just got to hurry and finish these really quick.
Oh, you're fine.
2 seconds. So on this, wait, oh, I see what I did wrong there. Okay. The second one I'm getting the 0.0625 is that right?
You mean the third one?
Right. Yeah, third one.
Yeah, that's right.
Okay. And the fourth one. Can you hear me?
Yeah.
Okay, so I got 0.5625 for number 4?
Yep.
Yep.
Okay. And then for the standard deviation, don't you add all those up and then take the square root, right?
Yep.
Yes.
Okay, so. Okay, I'm good.
All right. Awesome. Okay. So do we want to go on to the quiz?
Sure.
I wish we could do the homework assignment together in the homework quiz, because that kicked my rear last time. I don't know about you guys. Whew.
Yeah, I did.
What did you guys get?
I got a 70.
Yeah, I got a 72, and I felt like I emailed him and asked him which ones I missed,
Yeah.
and I was like, I felt pretty good about it, and then I was like, oh, 70.
I did too. I thought I understood the concepts, and I did really good on my homework assignment.
Yeah,
And then I took the quiz, and I'm like, what?
yeah. Which
Is this the same lesson?
did you ask him which ones you guys missed?
Well,
or-
now that it's been graded in the
Gradebook thing.
Uh-huh.
now that it's graded and the due date is passed, you can go back and look at what you chose and what the right answer is now.
Oh,
on
really?
details. Yeah, just like you do on the quiz ones. On the group quiz ones, how you can do that, you can do it on the homework now. So I just went through and copied and pasted it.
Yeah, I need to
Okay.
do that and look at mine again. Because I felt good about mine, but yeah.
I was like, I thought I understood that. I was so mad. It ruined my whole weekend. I was like, ah.
I was just hoping it was the same as the other quiz because it marked, on the one you let us retake, it marked 3 of mine wrong, even though I had the right answers.
Yeah.
He emailed me back and was like, I don't know why it marked these wrong, they're right. And I was like, oh, good, because I was trying to figure it out, and I couldn't and I'm like, what am I doing wrong?
Yeah.
Now, will he go and do that automatically for him, or will he go to ask?
Lily, what?
That one he did it automatically. I think because we'd asked to take the group quiz again. So that one he did it automatically. But I don't know.
Okay.
Yeah,
Because on the group one, I'm 3 of them, and they were right. He's like, the auto grader just did something weird. So I don't know.
that is weird.
Yeah, I was bummed about that.
Bummed is a nice word about that. I was devastated. I'm like, 70! I tried so hard.
I know, and it lowered my grade 7%.
Oh,
Yeah.
yeah.
It's ridiculous.
Yeah.
Plummeted. I was like, ouch. I'm glad we retook the group quiz.
Yeah.
Yeah. I agree.
That's what I was thinking. Oh, thank you for being kind, because you knew I would do damage by myself. I didn't need any help.
Yeah.
Yeah.
All right. So do we want to take the group quiz?
Yeah.
Yeah.
Hopefully together we can make it through unscathed.
Need 100% on this one.
I know, for real.
Okay.
I think we just need to make sure we always go back and
Yeah.
just reevaluate kind of.
Yeah.
Maybe slow down a little bit.
Okay.
All right. Everybody ready?
Yep.
Yep.
You have it pulled up? Let's start.
I got the first 2 right.
Yes.
I can always count on getting at least a 20%, right?
Yeah.
Okay.
You want me to start reading number 3?
Yeah, that'd be awesome, Taylor.
Okay, so give all your probability answers as decimals. For example, 0.1234, do not give probability answers as percentages.
Okay. I will not.
Okay. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. So, as you can see, that O is 0.45, A is 0.40, B is 0.11, AB is 0.04. Use this data to answer the following questions. the blood types and the proportion given in the table above does define a probability distribution.
Seriously.
Well, the probability distribution isn't that? That's the 3 rules. So
It would have to equal 1, right?
yeah, which it does. Well,
It
just
does?
one.
Somebody's
one.
good at math.
That's it does. Yeah. Yeah, it equals 1.
Yes. I would say yes then.
So it meets the first one. It's between 0 and 1. Meets the second one. It equals 1. And then the third one. How do we?
Well, I mean, you can find out. That's actually.
Does it just have to meet one of the rules, or does it have to meet them all?
I think all 3, doesn't it?
I thought it was just 1.
Well, I mean, it does fit the rule, because if you want to find out which one will not have A, you can subtract A from O, B,
The rest
A,
of
B.
them.
Yeah.
Okay.
Yeah, A from 1, and then you'll find, yeah.
And then
I think it's true.
Yeah.
3.
All right.
Okay. I'm going to read number 4. What is the probability that a randomly selected person in the United States has type O blood? Round to 2 decimal places.
Okay, I heard that.
Would it be just the 0.45?
Well, isn't it 0.4? Wait.
What is the probability that a random has type O blood?
Yes, because if you put all of those things into a hat and pulled it out, you have 0.45% or 45%, which if you make it a decimal would be 0.45. So yeah.
Yeah. Everybody agree?
Or would it be?
Easy though?
Or would it be, since there's 4, so it'd be 1 in 4 chances, so 0.25.
But it's not like a dice.
It's not like a dice.
Because it's not evenly. I don't know. I was thinking of it as if you take a random, like thinking about the random is that at first it might not make sense. So if you randomly select people, like you might get a bunch of people that have A blood or B blood, but in the long run, after you test enough people, you'll get to you'll start to see the values that it has right there, the proportion of 0.45, 0.4. Because it's not, the blood types aren't distributed equally, like the size of the dice.
Yeah, that makes sense.
Well, it's like you think about in the reading how it was like Columbus and he had like a 1 in like 42 chance of or whatever.
Yeah.
Of marked chickpea. That's the same type of thing. If you put all of these in, there's 0.45 out of 100.
Yeah.
O's in a bag or whatever, that you can pull out.
Okay.
That makes sense.
Yeah. So is that what we decided? 0.45.
0.45. Only 2 decimal places.
Okay.
Okay, so I'll do number 5. What is the probability that a randomly selected person will not have type O blood? So this is where we would take the 1 minus the 0.45 and we would find, right?
Yeah.
Because rule 3?
Yeah, that's rule 3.
Okay, so 1 minus 0.4.
So 0.55.
Yep.
What was it?
0.55.
0.55. Okay.
How'd you get that?
1 minus 0.45. Because basically since we're not doing percentage-wise, it will equal up to a 1 is the sum. Does that make sense, Greg?
I did it the other. Oh, never mind. I just did my math now.
What?
I got 0.65. I must have added something wrong.
Let me do it. 1 minus
Yeah, no, it's 0.55.
0.45. Okay. Yeah.
Easy enough.
Okay. On to another whole big paragraph. All right. Greg, do you want to do this one?
Sure. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tango, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in random order. 6 of the samples were patients who did not have bladder cancer, and 1 of the samples came from a person identified as a bladder cancer patient.
Oh my
The
goodness.
dog guesses at random what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient. Round to 3 decimals. So wouldn't it be, there's 6 samples from people there's 7 total samples, right?
Mm-hmm.
So it'd be a 1 in 7 chance.
Yeah.
Yep. Then 1 divided by 7.
0.143.
And it's 3 decimal places.
Yep, 0.143.
All right. That's all I'm writing.
0. What did you guys get?
143.
Oh, okay.
Because you
So
round
0.
to the decimal place, so the 8 would bring the 2 up to a 3.
Okay.
So 0.143. Okay. Taylor, your turn again.
Okay. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There is little evidence that dogs can detect bladder cancer. So out of 54 trials, they identified it 22 times.
So 41% of the time they got it right. Right?
I'd say that provides strong evidence.
That's like an opinion. It's not fair. It's like,
It's kind of
yeah.
giving you the answer though when it says it is very unlikely that the dog would do this well by random chance alone. So that means
But it
that,
is possible.
yeah, that provides strong evidence that dogs can detect bladder cancer. I don't know. Oh man.
I think I would say it provides strong evidence that they can. It doesn't mean that they're going to every time,
Yeah.
but I think that they can.
Yeah.
True.
I mean, obviously with a little bit of help, like with them putting out the 7 dishes and 6 of them had or didn't have the bladder cancer in one dish, so they smaller the samples. But after doing that 54 times, 22 times right, I'd say that's pretty strong evidence.
Yeah. I'm going to go with this provides strong evidence. What do you guys think?
I agree.
Do we concur?
Yeah.
What about you, Greg?
Yeah, let's go with it.
Peer pressure. What do you think? Okay. Jenica.
Okay. M&Ms are small chocolate candies. The M&M's website previously indicated that in the United States, the distribution of colors in the bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what is the probability of red colored candy? So, 0.13. Wouldn't it be 13% or 0.13?
Yeah.
Pretty sure it would, yeah.
Okay.
Is your guys' green like scratched out?
Yeah, because the next question asked us to figure out the green.
Oh. Okay, so 8 would be just 13% or 0.13?
Yeah.
Yeah.
0.13.
So what is the probability that randomly selected candy is green?
Okay,
So
so
you would add up the brown, the yellow, the red, the blue, the orange, get
And then
that
what you
sum, and subtract it by 1. Like 1 minus that sum, right?
Yeah. So it'd be 0.16.
yep. That's what I got.
You guys are
Yeah.
fast. I'm still working.
0.16.
Yep, that's what I got too. 0.16.
So then what is the probability that a randomly selected candy is not green?
Isn't it the 0.84?
1 minus, yeah, it would be the 1 minus 0.16, so 0.84, right?
Yep.
Nice. No math there. We already did it. Okay. I guess I'll do the next one. The ACT scores of students admitted to a medium-sized public university in the western United States were taken from CAPEX, I don't know, whatever. The following summary statistics were calculated. Use the information from the public university to answer the following questions. Half of the observations are less than or equal to what number?
No, would that be the median?
That's the median, right?
Because the median's you take all the
The
data
middle.
and it's the middle number.
So that would be 24. Don't you think?
I think.
Yes.
Okay. Well, these are review questions. How nice of him. Thank you.
Okay.
Based on the
So
information.
11 was 24, right?
Yeah.
Median.
Yes.
Okay.
Okay. 12. Is it your turn, Taylor?
Yeah, based on the information on the table above, the top 25% of the students scored above what number?
That'd be the Q3, right?
The top. Yeah, because it'd be like the 75th percentile, right?
Mm-hmm.
So above that. Yep.
So 27.
Yes, that's what I'm thinking. I concur.
I heard that word a lot today. I don't know why.
I like that word. Okay. Jenica, is it your turn or Greg? I can't remember.
I'll go.
Okay.
So, which of the following statements is not one of the 3 rules of probability? The probability that an outcome will not occur is 1 minus the probability that it will occur. That's true. If the probability is high, then the probability is positive. The probability is low, then the probability is negative. That's false. You can't have a negative probability.
Yeah.
Good job, Greg.
And the other 2 are correct.
All right. Do we want to review it real fast?
Yes.
Yeah,
Just
let's
because
go back.
we don't, that's when we're going to miss something stupid.
Okay. So number 1 is true. Number 2 is true. Do we have that?
Yeah.
I think so.
Sorry, couldn't help it. Okay.
You know what's funny is it actually had false because if you just scroll down instead of like clicking down, it'll change your answers.
Yeah.
Oh.
If you click the down arrow.
Yeah.
Don't scroll down.
Yeah.
So true and true. See, it's a good thing I went over the answers.
Yep, it is.
Okay. So we decided it's a probability distribution. On number 3, it's true because of the rule that it all adds up to 1. Right?
Yeah.
Yep.
Okay. Then we just looked at the table for the 0.45 for number 4. And that's 2 decimal places, so we're good there in our rounding. Okay. Number 5, 0.55, right?
Yep.
Okay, and that was 2 decimal places. That's what I'm looking at. Did I do the decimal places right? Okay. Number 6 is 0.143
Yep.
Yep.
because we did the 1 out of 7.
Mm-hmm.
Okay. We decided that that's strong evidence. Because how much percentage was that, Jenica?
It's like,
If they did it 22 out of 54 times?
it
It was like,
It was like
41%.
1%.
yeah.
That's pretty high.
See, the other thing I started thinking, like, the more trials they do,
Yeah, I think
the
that's...
more it would become correctly. So I guess, I don't know. I mean, and I guess that's true with any replication of a trial, but
Yeah.
it would provide, I think, stronger evidence every time. So
Yeah. I mean, if you take it down to 7 trials, it's like a 2.8 percentage.
out of 7,
Now that sounds like little evidence.
yeah.
I don't know.
But I think the key here is where it says it is very unlikely that a dog would do this well by random chance alone. It kind of has to be set up for them to be able to do it. And once it's kind of set up for them, then they're getting it like 41% of the time. So I think that's pretty strong evidence that they are.
Yeah. I think that's the key sentence, too, that kind of leads me to feel that it's the strong evidence answer.
Yeah. Well, I'll put strong.
All right. Let's hope those dogs have strong evidence, because that's what I'm putting.
Yes.
Okay, so the red colored candy was just looking at the proportion, the 0.13. The green was adding it all up and 1 minus the sum of the other ones, 0.16.
Yep.
And then the sum of the other ones, other than the green, is 0.84. And then our review questions, half, like the 50% is the median, so that'd be 24. And then the top 25% is the 75, so that's the Q3, so 27. And then 13. I think we got 100%.
At least a 95.
What?
At least a 95, if nothing else, you know.
Yeah.
Yeah, let's see, 12 out of 13 for that strong evidence one.
I
That's
know.
that's a 92.
92, that's pretty good.
All right, let's submit it. You guys good with it?
Yeah. Let's see here.
100%.
Woo! Yeah!
Ready?
All right.
Finally, holy cow.
I know, we are not 100%.
I needed 100% to make up for my homework last week.
Yeah, really. Ooh. Sweet! Yes!
Well, hopefully the 100%, or I mean the homework for this week won't be too bad either.
I started doing it, and it actually is pretty, it's kind of like the M&M's one and those kind of questions that were in this quiz.
Oh, nice.
Like
Okay.
probability using the rules, like add it all up, -1, da-da-da-da. So,
Well,
Yeah.
let's hope it stays that way for the quiz.
that was what frustrated me, is I didn't feel like the quiz was what our homework was.
Well, and I didn't feel like I did that bad on the quiz. When I got done, I was like, I nailed this quiz. And then when I got my score, I was like, not so much.
Yeah.
Yeah.
So,
Yeah.
Well, he kind of warned us in the introduction video that we're probably not going to have our straight A's like we are used to.
I know. Which is a pain because I feel
I
like I
know.
worked my tail end off in this class.
I know. I've worked a lot harder in this class, reading all the textbook stuff and meeting every night with you guys. Not every night, but every other night. And no,
Yeah.
I'm glad our group is a good group.
Yeah, honestly.
All right, so I saw something that someone else did is they posted the link to the video, and then they put who attended underneath, like in their comment thing. And I was like, that's a good idea. So I'll start doing that. I'll just put who attended.
okay. And have you watched the video that he sent out to us?
Yeah, he said that will start next week, but.
Oh, no, I
that-
haven't had a chance
yeah.
to watch it.
Yeah,
That
so-
he'll actually start grading the group collaboration.
Well,
Yeah,
that, and once Lexi posts it, one of us is supposed to go click on the link just to make sure it works.
Oh, yeah,
Okay.
that would be a good idea. I usually click on it and make sure it works, but it'd be smart just to have like two, make sure that it works. So, yeah. And then if you guys want to just reply and say, hey, it works, I was there,
and
or whatever,
yeah,
So- just so he knows that somebody checked it and that I know that somebody checked it. So I know it
Yeah.
works.
Okay.
Cool. All right. I'll post it on the group collaboration place, whatever that's called, board thing. And next Wednesday, 7:30 Mountain Standard Time. Good for you guys still?
Yep.
Yep.
Or not next Wednesday. This Wednesday. Sorry.
In 2 days.
In 2 days, yes.
Sounds good to me.
Yep.
Okay.
All right, cool. All right, well, have a great night. And oh, do we want to say a closing prayer or no?
Sure.
Oh, good.
We could thank him because that 100% is from him.
Yeah.
I don't think we would have done that by ourselves without the Spirit, peoples.
It's true.
So who wants to say our closing prayer?
I could say it.
All right.
Our dear Heavenly Father, we thank Thee for this opportunity that Thou hast given us to be able to meet as a group and to be able to work through the quiz that we had together. And we thank Thee for the blessing that we have to have a good group and to be able to be punctual and prepared to succeed in this class. And we ask Thee to please bless us that we be able to continue to do so, that we can also balance our time necessary to complete the other tasks that we have in our individual lives, and we pray for these things in the name of Jesus Christ. Amen.
Amen.
That was perfect, Greg. I've been struggling with trying to be a mom, and I'm sure you understand, Jenica.
Yes.
The wife, and Taylor, you understand with spouse, and oh man,
Yeah.
trying to balance it all. And
And I'm over here like,
hey, trying to be a roommate.
It's still
Roommate
hard,
is
Greg.
too.
Fine and the girls. Come on.
Go to your family home evening.
no. I was supposed to go to my fiance's family meeting, but didn't end up making it. But
It happens. All right. Well,
All
see you guys
right.
on Wednesday.
guys,
Hey, see ya.
bye.
Good night.
Bye.